Okay. Yeah, g'day everyone. Yeah, many thanks for the opportunity to speak here. Yeah, many thanks also to our sponsors for making everything possible here. And many thanks also to our organizational staff for putting on the conference. That's very much appreciated. Thanks, guys. Yeah, okay, so I'm Paul. I'm PTC on CPAN, and this is my first talk at a Perl conference, so I'm just a little bit worried, but anyway, let's do this. Thank you. Yeah, so this is a story about fixing an old curve fitting bug. Okay, so the backstory is basically I had a project where I download Arctic sea ice extent data from the satellite record, and then look at how that changes over time, and then do some plotting and stuff, and then actually fitting some curves and whatnot. That's a long story. If you want to know more, ask me in the pub. Anyway, I wanted to set this up recently, and so as you do, just cpan-m and install deps to actually get the dependencies again and get it back running. It's like, hang on, but the test is failing. This is really weird. Like, why? My expectation is usually that Perl just works. This is effectively because Perl's backwards compatibility is legendary. I don't know of many languages where you can take code that was written, say, 15 major versions ago of the language, and it still just works. So that's something that's actually, I find really awesome, and especially my daily work. And so as far as, the Perl core devs are doing a great job. So thank you also on that score. Anyway, like I said, this is weird, and the failing dependency was this thing called algorithm curve fit, which fairly obviously fits curves. Okay, so let's do a bit of a tangent, and I'll explain what algorithm curve fit is. So it fits a curve of a known form to a given set of points. So basically, if you've got some x data and some y data, you've got some formula you want to plot. So this is a parabola, for example. You give it some initial guess of what the parameters are likely to be. It runs away and spits out a curve back for you that fits your data. Pretty cool stuff. Okay. Yeah, but I hadn't changed anything. Well, I haven't changed anything. Well, of course I've changed something, right? It was a new laptop, it was a new operating system, fine, still Debian, but, all kinds of other bits and pieces were changed. I had to change the Perl version. This is still weird, right? I've not changed the code. This is an old project. So what had changed? Looking a bit further, so algorithm curve fit, it hadn't changed since 2010. My code hadn't changed since 2018, which is the last time I touched it, and really I hadn't done much. I tried installing the Perl version from back then, so that was like 5.18, just to see if that worked. I'm sort of grasping at straws really here. And then I thought, well, okay, so that didn't help either. Digging into the module, having a quick look at the source, it's just plain Perl. It doesn't do any funky low-level stuff, so why doesn't this work? I mean, we expect backwards compatibility, and yeah, it was funny. You trip over something which you didn't sort of notice in the street. Anyway, also Perl has a great testers community, and consequently others had found this problem. I mean, fairly obviously, because lots of testers out there. And this was an interesting bug actually, because it happened between Debian Jessie and Debian Stretch. What could have caused that? That's really odd. This is beginning to get interesting. I can feel myself being sort of drawn in to, so there's some kind of vortex of the bug is going, yeah, I'm interested, come and play with me. But it won't take long. Let's have a bit of a dig. Anyway, sometime later. So a bug hunt ensued. And when I'm bug hunting, I like to be prepared. I like to make sure that I've got a known base level where everything works, right? It's sort of for some value or whatever, works means. It doesn't matter, it's just sort of to know, here's the thing that works and here's the thing that doesn't work. What's the difference between the two? And maybe we can find out what's going on. Okay, so we have to go back to Debian Jessie, but it's 2024 and Jessie is old. Well, we can probably do this in Vagrant. Let's have a go. So here's the Vagrant file that I used. Jessie, a 64-bit Jessie system, set up some network stuff, blah, blah, blah. Start the virtual machine, boom. What now? Sort of working with legacy code, right? It's always going to find something dodgy which doesn't work. This turns out looks probably bad to start with, but it's not that hard. So the reason is that because Debian Jessie is really old, there's no repository or no official repository for it anymore. There is an archive repository for it, which means that once you update the sources.list file for that, everything just works again. So you can do apt update, apt upgrade, and then install the tools that you need. So for example, here I needed curl in order to be install Perl brew and the build essential package so that you've got make and the C compiler, etc., to be able to install Perl. Sweet. Okay. So install Perl brew, standard stuff, and then finally install Perl, also fairly standard stuff with Perl brew. Interesting thing here, I used 5.18 because that was the version that had worked for me in the past. So again, this is me trying to sort of reduce some kind of blast radius of, reduce the number of things that are different with each thing. And I had to use no test for when actually installing Perl because for some reason the nanosleep test fails. I think this is because this is running in a Vagrant VM. I don't know. There are brainier people than me here who might actually know that, so it'll be interesting to know that. But anyway, something to talk about at the pub. Okay, we've got a running operating system. Let's see if algorithm curvefit installs. Yay, it does. Okay, cool. We've got something that's going. We're moving forward. But just installing from cpnm is not sufficient. So I grabbed the tarball. So I've actually got the code to play with, and run the test for that. So it builds, built the make file, ran make test, everything passes. Okay, getting there. Now we need to start drilling down. We've got this running system, but we need to get sort of down to sort of the specifics of where the problem is occurring. Okay, so let's run the test that fails, so to speak, in the future and see what the output looks like. Oh, it's not overly helpful. I mean, everything's okay, but right. So let's do post Jessie, so to speak, and see what happens there. So in other words, we're outside the VM now, and for example, on my laptop, running it again. Okay, that doesn't help much, but we know at least that this is the third test in this particular suite that's not running. Awesome. Now, someone made a good suggestion in the RT ticket to use the compare OK function to get a little bit more information. So we give it a little bit more detail. So the thing here is that we've got some value which should be greater than 5.15, but it's only 5. And the question is, well, which value is this? For that, we have to actually open up the test code and have a look at that. So what the test code does is we've got a list of expected values. We've got a list of tolerances on those values. So for example, here we see that the first value is 5.15. So obviously the issue is occurring with that particular number. And the tolerance on that is 1. So it means we expect plus or minus 1 on that. And then we feed the parameters array. These are the parameters, if you remember from the beginning, that are being passed into the curve fitting function. And then it goes through each of them and makes sure, are they within the relevant values? Okay, so looking a little bit deep into the code, we find that, okay, here's the parameters array in the test that's being used, and S is the first parameter that fails. Okay. We expect that S past its tolerance is greater than 5.15. The tolerance is 1, which means that S at the end of the test, when we expect the parameters array to have evolved because the solution of the curve fit has evolved to that point. That means that S is still at 4, which is weird because that means S hasn't changed, and that means that the solution isn't converging to what it should be doing. Okay, so why not? I could have been really elegant here and stuff, but data dumper is your friend, right? You just sprinkle print statements all over the code, and then maybe something turns up. And yeah, so for example, here the calculated fit values. Anyone see the problem? Right there. There's 9 times 10 to the 20, so we'll say 10 to the 21, whereas everything else is roughly sort of 1 to minus 1. I think. So yeah, I come from a bit of a scientific background, and the technical term for that is wrong. Yeah, actually, a friend at university said, that's not wrong, that's not even right. It's not right, that's not even wrong, sorry. Anyway. So crazy things you think of. Yeah, like I said, I've done some stuff in scientific computing before, and if you see numbers like that, this smells of like, you know, someone tried to divide by zero somewhere. Yeah. Okay, so let's have a look at that and see if that's the case. Now, algorithm curve fit is pretty cool because you can give it a string of the formula that you want to use, and it will actually do a lot of stuff symbolically. Consequently, yeah, it's able to do a lot of this information symbolically, so it actually is really quite powerful in the background. But that's not easy to look at. So let's write this a little bit more nicely. So we've got some function, it's got a square root with a constant term. Okay, what does that actually look like, right? So plot the curve. So one thing I like to do is actually get a bit of an intuition of what the data looks like. Maybe it's just a scientist thing. Anyway, we've got this nice hockey stick function here. And it turns out that, you know, things get interesting, so to speak, around this point. And this is at where x is 1.05. And this is where the weird numbers are turning up in the tests. Okay, so yeah, we might be onto something here. The fitting code inside the module uses the function's derivative in order to fit everything. And well, given the test name is bad deriv, so obviously there's something, you know, fishy going on here. So let's have a look at that. That's the function's derivative. I didn't do that by hand. I actually did just use conversational mathematics package to do that. So I think the high school students that I tutor will probably be disappointed with me right now. But anyway, let's have a look at the curve. Also, this curve does funky things around about 1.05. You can see the sort of change, and you can sort of think, oh yeah, okay, some piece of code is seeing something changing far too much. Must be something going wrong there. Right, okay, so what could be going on there? If we look at the denominator of the derivative, we see that we've got this x minus x0 thing there. So that's something that is effectively a critical part of this function, is when when this number tends towards that number, basically. So if we set x equal to x naught, we get square root of c. But we know that c is 0.01, sorry, which means the square root of c is 0.1, and that's not small for a numerical issue. Yeah, I'll be sort of expecting 10 to the minus 12, 10 to the minus 13, sort of, you know, around those kinds of numbers. Okay. Let's look a bit closer. The output, let's go back here. These were calculated fit values of the actual function itself, not the derivative. So that means maybe the function itself is dodgy at x0. So let's look at that. So we plug in x0, do some calculations, we get 0.2. This is not on the order of 10 to the 21. This isn't numeric, so, you know, okay, wild goose chase. Sometimes, you know, if you've got to stare at the code, you can sort of have a withering stare and it will submit to your gaze, you know. Sometimes that happens. Sometimes things sort of jump out at you. Anyway, the code uses a symbolic derivative, and if it can't use that, then it falls back to a numerical method. That happens in here, where it gets the values of the actual function in order to do the numerical derivative calculation, and this thing called formula sub. Anyway, so the parameters array that we've seen a couple of times before gets passed into here. So, but the main thing is happening sort of roughly in that chunk of code. Now, because I've put printf basically all over the place, in the noise, sometimes the parameters array passed into formula sub look like the stuff on the left, and sometimes the stuff on the right. And I remember thinking at the time, that's weird, but I must have been tired because, you know, this didn't ring warning bells, and it probably should have at the time. But anyway, it was also quite handy that this formula sub thing was used in different contexts. So this actually, you know, sprung out at me eventually as being sort of something different, because I would have probably thought, oh, this is the normal sort of case. Anyway, so in some contexts, formula sub was used like this. Now, this is when the code is calculating the numerical derivative was used like that, and sometimes it was used like that. Does anyone see where the problem is? Okay, I'll remove extra crap from it. Basically, what's happening is you've got that, it's used like this in one situation, and it's used like this in one situation. You know, when you're staring at code, you go, what's that map doing in there? Hang on, that wasn't present up here. Aha. Yeah, so what I think is happening here, well, I'm vaguely sure what's happening here. The map passes the values of the parameters into formula sub. Whereas previously, with this up here, we're passing just the array as the second parameter. That's wrong. Formula sub actually just expects a list of scalar values. This also explains the nested structure that we're getting in here. This is basically the array getting splattered across what, realistically speaking, should be parameter plus its value, parameter plus its value, etc., etc. Okay, where do we go? Okay, yeah. So changing that to using the map form, fixes the bug, and the test passed. Woohoo! Okay, awesome. I'm really stoked about that. And I'm like, but hang on, this doesn't explain why things fail between Jesse and Stretch. I mean, this isn't independent of operating system, and that would mean that the big numbers must have occurred back in Jesse. So having a dig, I found things like this turning up in the data. It's like, okay, so it existed in the original code, but why did the test suite pass? So my guess here is that you've got this big number, but it wasn't sufficiently large on the Jesse system for the solution, or for the curve fit thing to actually evolve to the correct solution. However, if you make this number 10 orders of magnitude larger, it never gets the chance to evolve. So you've got something that's sitting there, and basically the solution never evolves, and consequently the test suite fails. Now, this is where I get a little bit sort of hand wavy, more than I've probably actually been doing through the entire talk, is because I'm not 100% sure how this works. Anyway, I've got some things are sort of smelly. Basically, the parameters array is effectively passed as a memory reference, and I'm thinking that this is like you've got a memory reference being passed as a scalar value. It's like you're using the value of the scalar and not the value of the pointer that the scalar. You're using the value of the pointer, but not the value that the pointer is pointing to, which could be any weird number. Now, what's odd is that you end up, if you consider 32-bit number, for example, max int of that, you get something that looks like this, and if you use a 64-bit number, you get something which looks like that. Now, what's weird is that these two numbers are 2 orders of magnitude smaller than the numbers I'm seeing. And the digit sequences are very, very similar. They change a little bit between runs, but you always get 2 something and 9 something. So there's something kind of bit width associated in here. And I couldn't find anything. I mean, I dug. I looked at GCC. I looked at the differences between Jesse, the change logs between Jesse and Stretch. There were some switches in GCC which had changed. I really couldn't find what had changed here. So if anyone's got any ideas, I'd really be interested to know what's happened. Note that this was Jesse is a 64-bit system, so I'd sort of expected that we'd be using 64-bit numbers. Okay. Anyway, now, cool, I've got a fix, but how do I get this out to CPAN? I mean, this is an old distribution, and the author didn't seem to be active. So on the off chance, I sent an email to S. Müller, and he answered. I was totally stoked. I was really, really stoked because, I mean, he didn't seem to have been active for a long time. And he's been incredibly helpful. It's been really nice because he's gone through his old laptops and computers trying to find the original code. And unfortunately, the code's been lost. However, he dug a little bit further and managed to find the original repository buried within another repository in an archive on GitHub. So we've extracted that code and its commits, we've put it up into a new GitHub repo. I've got co-maint on the disk, so I'll push a fix at some point. And while I was on the Eurostar coming across here, I was in France before we got into the tunnel. I actually pushed the fix in this talk, so watch this space. Yeah, unfortunately, bug fixing like this is lots of fun. So I had a nice time doing this. I've also gone freelance recently. So if you like someone who, to stomp on your bugs, increase test coverage, solve other problems, or try and pack 40 slides into a 20-minute talk to me. Thank you very much. Do we have time for questions? Yeah. Yeah, it's expecting a range of values. Yeah, yeah. And what's interesting with sorry. Um, uh, so it's not the tests aren't expecting. The question was that the tests aren't expecting a range of values. That they aren't expecting exact values. They're expecting a range of values. Yeah, yeah, you're quite right. They're expecting a range of values. I think this is because it's using some numerics in the background, and you're going to get some kind of variation. And so you expect, okay, it should be within that wiggle room. And I think the reason, I mean, if you look at the stuff that worked on Jesse, there wasn't much wiggle room. It actually really did converge to a nice exact number. So the 10 to the 11 kind of anomalous number, which were turning up, didn't actually have an effect on the solution, the solving of the curve fit. Only once you got this much more enormous number did it completely screw up and not bother to evolve the solution. So yeah. Yeah. Any more questions? Cool. Okay. Coffee.